Now let's proceed for the next chapter, chapter 10, simple linear regression and correlation. First, let's have an introduction. What is simple linear regression? Once we have identified two variables that are correlated, we would like to model this relationship. We want to use one variable as a predictor or explanatory variable to explain the other variable, the response or dependent variable. So we have here what we call the scatter plot, where this is the x-axis and this is the y-axis. At itong red dots na nakikita natin dito, yan ay ang mga it represent yung mga observations na galing sa dataset. So take note that a simple linear regression model is a mathematical equation that allows us to predict a response for a given predictor value. Empirical model. Empirical model means a mathematical formulation whose various reaction rates and input parameters are determined through empirical formulations based on literature reviews. The simplest empirical model is a dilution model. So basically, ang empirical model is a generic term for activities to create models by observation and experiment. Simple linear regression model. In the simple linear regression model, the dependent variable or response is related to one independent or regression variable. So ito ang formula natin for a simple linear regression model, where the epsilon is the random error term, and the parameter beta sub o and beta sub 1 are called the regression coefficient. So let's have an example for the empirical model. In order to conduct an experiment to measure the stretch of a spring as a function of mass, a spring mass system is considered. The following data is obtained. So ito yung given na where we use grams for the mass and centimeter for elongation. So for the solution, the data suggests that the elongation is proportional to the mass, finding linear regression result. So y is equal to 0.015 x plus 0.324 with coefficient of determination R2. R sub 2 is equal to 0.9985. Take note that the initial value is not that small compared with the size of first y value. Thus suggests that 0.324 is the elongation of a spring due to its own weight, and that the data is better to be modeled with linear regression than just with proportionality. So another option is to consider a power model. So y is equal to 0.029 times 0.901, and for our r sub 2 we have 0.9984. Suggests that this also fits data well. So take note again that the exponent 0.901 is close to 1, and so it can be argued that the data is close to being proportional. Next is correlation. A correlation exists between two variables when one of them is related to the other in some way. A scatter plot is the best place to start. A scatter plot or scatter diagram is a graph of a paired x and y sample data with the horizontal x-axis and vertical y-axis. Each individual x and y pair is plotted as a single point. So we can see here the scatter diagram for just G versus the length. Correlation also refers to a process for establishing whether or not relationships exist between two given variables. So through this coefficient, one can get a general idea about whether or not two variables are related. There are many measures are available for variables which are measured at the ordinal or higher level of measurement, but still correlation is the most commonly used approach. Take note that correlation is defined as the statistical association between two variables. So to better understand what is correlation, let's have this example. Calculate and analyze the correlation coefficient between the number of study hours and the number of sleeping hours of different students. So we have here the given the number of study hours 2, 4, 6, 8, 10. This is our x-axis, and number of sleeping hours 10, 9, 8, 7, 6. This is the y-axis. So in this table, we have here the x and y, where kung saan ito yun, 2, 4, 6. So in getting the summation, just add lang tong mga to. So ito yung 30 is the summation of x, and the summation of y is 40. So dito naman we have sa x bar, ang formula natin dyan is this. X bar is equal to summation of x all over n. So substitute na lang natin yung given, where summation of x is equal to 30 all over n, yung bilang nung given. So is equal to 6. Para makuha tong negative 4, i-kuhan lang natin so i-minus lang natin yung x sa x bar. So 2 minus 6 is equal to negative 4. Then 4 minus 6 is equal to negative 2. 6 minus 6 is equal to 0. 8 minus 6 is equal to 2, and 10 minus 6 is equal to 4. Then to get the summation of x minus x bar, add lang natin to. So is equal to 0. Then same din dun sa y bar. Dito sa y bar, the solution y bar is equal to summation of y all over n. So substitute summation of y is equal to 40, then the n is equal to 5. So 40 divided by 5 is equal to 8. So same process din yung gagawin natin dito sa y minus y bar. So the summation of y minus y bar is equal to 0, as we can see here naman. Next table is x minus x bar times y minus y bar. So pag-multiply lang natin tong dalawa. Ito yung sagot. Then for the summation of x minus x bar times y minus y bar, add lang natin to. Negative 8 plus negative 2 plus 0 plus negative 2 plus negative 8 is equal to negative 20. Then dito sa x minus x bar square, i-square lang natin tong negative 4. So ito yung sagot, 16 square negative 2 square for 0, 2 squares 4, and 4 square is 16. Same process din dito sa y minus y bar square. So, we have here the scatter plot of number of study hours versus the number of sleeping hours. So, makita naman natin dito. Ito yung itsura ng scatter plot ng number of study hours and number of sleeping hours. So, in conclusion, there is a perfect negative correlation between the number of study hours and the number of sleeping hours. So, that's all. Thank you.